This week's lab, we're going to look at wood biology. And we're going to start to look at the processes that take place inside the wood after a tree is injured. How does a tree defend itself? So this week, before you come to the lab, I'd like you to watch this video and just get a sense on what it is we're doing in lab. So we're going to talk a little bit about dendrochronology. Now, what is this? Essentially, when we're looking at trees, it is the journal of the tree, the history of the tree, locked away in the tree rings, in the growth rings. So as we'll discuss over these next few weeks, trees do not heal themselves, they bury themselves in wood, bury old injuries in wood. So there's a lot of stories that the tree can tell us just by looking at the growth rings. And so researchers use dendrochronology to look at climate change, to study climate change, and how tree growth, especially some of the oldest ones in the world, such as these redwoods, have changed over thousands of years. This helps to predict weather patterns and also to help us to learn about weather patterns in things that may have happened in the past. There's times to document insect outbreaks and times of stress for the trees. We get a sense on when fires were, where major fires were, what kind of fire cycles there have been in the past. And to help us date history, not like the matchmaker dating history, but more so dating history, as in to find out historical events that took place. Sometimes major world events, major volcano eruptions and things like that may have had global impacts, and that can often be seen in the rings as well, because it would have affected the tree health or tree growth during that time period. So I want you at station 1, you'll notice up here station 1, this is one of our stations that we're going to look at in the lab this week. So station 1, you're going to have a few samples of wood out. Just grab a sample, we'll have a questionnaire for you to pick up when you come in. Just go to station 1 and look at the growth rings, look at the cross section of a tree, and go through the handout answering the questions that we've prepared for you. Okay, tell the story, and this is essentially what you're going to see. You're going to see a wood sample, maybe something like this, and then tell me the information that you can from this. How old is it? It's just a simple count the growth rings. But try to put together what sort of thing may have happened. In this sample, we have an injury on a tree, and we can count from here how many years ago that injury happened, because these are how many years of new growth has come on since this tree was injured. Okay, there's other significant things that happened for this tree. Look at how tight the growth rings are in this original tree before the injury took place. Okay, this tells me that this tree was growing in a situation, maybe in a forest, maybe in growing conditions where there were limitations. Okay, so in this case, probably light limitations. The forest it was growing in was overstocked. The trees were very, very crowded, and so growth was very slow for this tree. Something happened, and after this injury, suddenly this tree started to put on much more growth in 1 year. Okay, so now if we use that information to know that something happened within a forest, a disturbance took place, this tree was injured, but it survived the injury, and after that growth sped up. So that tells me that there's been an opening in the forest after this injury took place to allow this tree to put on a lot more growth. If we know a little bit more about the site of this tree, it was a spruce, and this was the upslope side of the tree, and it was growing on a mountain. So now we put that information together, and that tells us that there was an avalanche. It came down, wiped out a lot of the neighboring trees. This was the damage from the avalanche, but since it survived that, suddenly a lot of the tree's neighbors were gone, and it allowed the tree to respond by putting on larger growth rings after that, because it had so much more space to grow. There's another wild story, and these are some great photos from a tree ring gallery. The reference is down here. Great website. It's on D2L for you to check out as well, where it's just an analysis of different tree rings. This one's from giant sequoia, with some pretty wild growth patterns, and you can see here that there's this line, the separation of the growth rings in an injury, and then the wood buried over top. So again, you can count the growth rings, how many years it took to grow over top of this injury. Then the injury happened again, and it sealed and grew over top. Injury happened again, grew over top. and again out here. So this is numerous years of regular forest fires that went through, burned, caused some damage to the bark, but the tree, because these are pretty fire resistant trees because of the thickness of their bark, the tree was able to survive and grow over top. But given that the fire was all in the same direction every time, that tells us a lot about the fire patterns, the weather patterns, the intensity of the fire, and the tree's ability to recover from that. Okay, when you don't have a stump, okay, some of the oldest trees in the world, such as this lone little white cedar growing out of the Niagara Escarpment, these are some of the oldest trees in Ontario in this case. Some of these trees have been documented to be upwards of 800 years old. We're not going to cut them down and look at the cross section to count the growth rings, obviously, because that's crazy. So in that case, when removal is not an option, we can get a little snapshot of this tree by using an increment borer. Okay, so if we use an increment borer, most of you will know that this increment borer is a drill with a hollow core in the center, so that we drill into the tree and we pull out a core sample like this. And then, although it's just a small sample, we can still get a sampling of those growth rings to find out times of slow growth, times of faster growth. Okay, and you can see the cycle in this sample where we've got some slow growth and a release, where the tree grows more quickly. And then the forest started to get crowded again. There was a release, the growth rings extended. And once again, got crowded in a release. Okay, this is an indicator, because it's so many years, it's an indicator of the changes within the forest where something opened up in the canopy. If I saw one or two really tight growth rings like this, and then the rest were large, that's more of an indicator of dry seasons or weather patterns where the tree didn't have a good season in growth. But this one, because it's so many years that we see, and then a release for so many years, then that's more of an indicator of the changes within the forest as far as canopy changes. Okay, so station 2, so you're going to see 3 stations in this week's lab. Station 1 was dendrochronology, looking at growth rings. Station 2 is looking at wood porosity, and I'd like you to look under some of the dissecting microscopes that we'll have set up and look at the different porosity patterns. So you're going to see a ring porous pattern under the microscope. You're going to see a diffuse porous pattern. We won't see semi-ring, it's kind of a mixture of the two, but I'm just going to show you ring porous, diffuse porous, and then a sample of a conifer. And I'd like you to look underneath and just kind of make some notes and to observe what the differences are between these different pore patterns. Okay, it's important when you're looking underneath the microscope that you're looking at the right place. So what our instinct is, we look on the end excuse me, we look on the end grain, and people always want to look here, and that makes sense. You're looking at the end grain. But what you want to look at is right here at the corner where we've used a knife to cut the edge cleanly. Okay, a regular saw, when it cuts lumber, tears the cells and you can't get a good look at it. So we need a sharp knife to slice the edge of the wood, because it's going to be much cleaner. And then under the microscope you're going to look at this section. Okay, this is what's going to allow you to see what it is that you're looking at. Okay, and so those are our 2 stations. Our third one, there is an assignment, a lab assignment to prepare your woody slide, which there was a video on that showing the process for preparing a lab slide. Okay, so you're going to do those 3 stations this week in lab. I just wanted to kind of give you a heads up on this before you get in this week. See you in lab this week.